Hello and good morning. Today we're going to be going over resistance summation in either series or parallel. And so what we have on the screen here is we have a voltage source, two voltage sources, V1 and V2. In these two instances, V1, let's say, is going to be 12 volts. V2 is also going to be 12 volts in these two circuits. And we're going to go one at a time. So series, we have nodes A, B, C, and D because these R resistors, R1, R2, and R3 are being added in series. Very similar to algebraic terms, R1 plus R2 plus R3 is going to be a simple summation. It's going to be 1 kilo ohm plus 1 kilo ohm plus 1 kilo ohm. Resistor in series, R equivalent is R1 plus R2 plus R3 plus ellipses. So then 1 kilo ohm plus 1 kilo ohm plus 1 kilo ohm is going to be 3 kilo ohms. Okay? And then to determine the resistance, the equivalent resistance is 3 kilo ohms. And if we're going to do the V equals IR equation, V equals IR, or I times R. Let's have that over here. V equals I times R. So if we substitute 12 volts into V and R is 3 kilo ohms, 12 volts equals I times 3 kilo ohms. Then that means that if we isolate I, that's going to be I equals 12 volts divided by 3 kilo ohms. Okay? Contrary to how that simple summation is done, actually, the current is going to be 12 volts divided by 3 kilo ohms, so that's going to be equal to 4 milliamps. Let's see if that's what we get over here. 4 milliamps. Device current, I through R1, R2, and R3 is 4 milliamps, 4 milliamps. And in this parallel circuit, the resistors in parallel, we have V2 is 12 volts. We have two nodes, X and Y, and we have three resistors in parallel, 1 kilo ohm in parallel with 1 kilo ohm in parallel with 1 kilo ohm. So when we do the equivalent resistance of Req, the way that you set up the equation is going to be 1 over R equivalent equals entire quantity of 1 over R1 plus 1 over R4 plus 1 over R5 plus 1 over R6 plus 1 over Rn, entire quantity to the negative 1, or invert it, and then what we have is going to be, let's see, if I take out the calculator, so 1 divided by 1 kilo ohm is going to be 0.001 plus 0.001 plus 0.001. That's 0.003. So when we invert that, 1 over x, 1 over 0.003 is going to be 333.33 ohms. 333.33 ohms. So then let me write that here. R equivalent equals 333.3 ohms. And we could check our dot operating point again, run the dot op command, and here we have, let's see, V2 VA VX is 12 volts. Let's see, the current running through this would be 12 divided by 333 ohms. So let's take out the calculator. V equals IR, right? So 12 divided by 333 ohms is going to be 36 milliamps. And is that what we get in here? Yes, it's 36 milliamps in the dot operating point. Okay, so then that explains both series and parallel, and then we can get into more complex circuits. Thank you.